Okay, good afternoon, everyone. I'm going to talk about introduction to pathfinding algorithm. Before we get started, let me say a quick introduction. My name is Hiroyuki Momoi. I'm a full stack software engineer, currently student at Code Chrysalis. And most of my background is implementing Microsoft infrastructure solution. And in the last 2-3 years, I often use Microsoft Azure, Office 367, 5 or 365. And I have most of my experience as a project manager. And I use a Pinbox style and Scrum style. And now I'm currently building a web application. And my passion is develop route navigation solution for virtual users. One of the reasons I decided to switch job to software engineer is I love travel around the world and I always using some kind of mapping navigation, but oftentimes it doesn't work for me because it's not considering the stairway or elevator or gaps, something like that. So if I build my own some nice application for me, it works for me. So I hope it's not only for me, it's only for the people who have a problem with mobility. So it's good. So that's why I wanted to be a software engineer. And first I have a question. How many people using Google Navigation or Apple Navigation? Thank you very much. Everyone using. So here's your practice. On the left is Apple Navigation, and which is from Roppongi to Nihonbashi. On the right side is Google Navigation from Shibuya to Code Chrysalis. And today, this talk is for who are new to algorithm and interested in the route navigation. And I explain this algorithm in the JavaScript. So if you are familiar with JavaScript, it's also good. But don't worry, most of my presentation is using a diagram, so you don't have to know the JavaScript. So this is the agenda. I have 3 things. And one thing is, before we dive into the algorithm, a few things should know. So and after that, I explain the algorithm with diagram. And after that, let's implement in JavaScript. So some kind of definition. What is the pathfinding algorithm? The pathfinding or pathing from Wikipedia, it's too long, didn't need. So short, find the shortest route between 2 points. It's a pathfinding algorithm. And there are a bunch of algorithms in the world. So, and I'm going to talk about Dijkstra's algorithm because it's very basic algorithm and good for understand for beginners. And let me ask, how many people know Dijkstra's algorithm? Oh my gosh. Oh, so many people know. So if there's an expert, correct me if I'm wrong. And first, Dijkstra's algorithm, of course, designed by Edward Dijkstra, who is a Netherlands computer scientist. He designed the algorithm in 1959. And Dijkstra algorithm is one of the most famous shortest pathfinder algorithm. And this algorithm uses a directed and weighted graph. So first, I want to explain what is a graph. So a graph is one of the data structure, which is a non-linear data structure and consists of vertices or nodes and edges, and which connect a pair of nodes. And here's nodes and edges. And here it's a real example. Graph structure uses many famous companies. So on the left is a diagram visualization of Facebook connection, and it uses for graphs. And the right up one is LinkedIn connection diagram, and right down is some handwriting diagram is a Twitter connection. And I explained the graph has vertices and edges, and also in the Dijkstra algorithm we use another parameter. One is a directed, and graph can have directed or undirected. And for example, let's think about the Facebook communication. If I send you a friend's request, and when you apply, the connection is two direction. I'm your friend, you are my friend. But if it's a Twitter, I follow something, but this is one direction. I follow, but maybe he doesn't follow or something. So this is directed and undirected. And Dijkstra algorithm uses a directed graph. And one more thing is weight. Weight is some kind of edges parameter. It's similar to distance or time or something. And before talk about algorithm, every algorithm solves some kind of program. So we should know what is the program this algorithm solves. So this is of course a shortest path program, finding a path between two vertices in graph, and some of the weights of its consist edges is minimized. In the real case, the nodes corresponds to the intersection, and the edges correspond to road segments. And each weighted by the distance of its road segment. Here is Google Map navigation. Okay, so let's talk about how it works. And Dijkstra algorithms are basic 4 steps. Step 1, find the shortest node. And step 2, update the distance of the immediate neighbors of this node. And step 3, repeat steps 1 and 2 until you've done this for every node. And return the shortest distance to reach the goal and optimal path to do so. And it's thinking time. I give you 5 minutes and a piece of paper. So let's think what's the shortest distance and what is the shortest optimal path. Yes. Yeah. Okay, sorry. If you need a pen, stop. You stop. Stop.
Well, like,
You need to pen?
so you should be in my brain.
And here's some hints. Maybe we can use 3 types of memo. One is the distance, one is the keep track of the shortest distance to reach a node, and one is the path keep track of the node before each node. And visited is keep track which node has been visited. In the algorithm, maybe we can use 3 other data structure, other data store.
Yeah.
Finish? Hmm? If you finish, Ari, let's talk never.
So I have to have these air. Yeah. Oh, yes. Got it. What's the next?
Yeah.
Books, I'm just pointing. It's favorite right down. It's like, how do people in the point that's celebrating? What's each year? It's a good question. How does that work? Yeah. Happens on both networks.
Okay, time is up. Okay. Okay, let me ask, does anybody know the answer the distance and the optimal path? Okay. Somebody wait.
Have a guess?
Okay.
So I went from start
Yeah.
to C to D to F.
And shortest distance is
This is 9.
9. Okay. Everybody same answer? Oh, please.
Yes. Same answer.
Same answer? Okay. Maybe everybody gets. Oh.
The other option.
Let's check.
So start E F goal. Yes. Also 9.
Yeah.
Those.
Same.
Yeah.
Okay. So let's make things easier. I said the avatar is also hero. I wanna go to CC, and first, yeah, I'm here and home, and I find 3 connections, which is to B and C and E, and I write to my memo, and each knows and distance, which is B equals 3 and C equals 2 and E equals 3. And I wonder what is the shortest node before next time move, and I move to C, and I find the 2 connections which are to D and E. And to D, there are no nodes in my memo, so I write D and also write distance, which is a 3. And I found another connection to E, but I already know the E, and the shortest distance to E is 3. So if I go to E from home to C to E, it takes 7. So I don't want to override my memo to E. And next, I have 3 hasn't been visited nodes, which are B and E and D. So I move next B. I found the 2 connections, and I write in my memo new node G and distance equal 11. And also B has a connection to C, but I already know shortest distance to C is 2, so I don't override my memo. And next, I move to E. I find 2 connections, and both nodes is 2 new connections. And I like in my memo F and I, and also distance 6 and 10. And let me ask, which node should I move next? Anyone? Again?
Well, D looks like the shortest
Yeah.
of the unneeded node.
Yeah, correct. I move next to D because D is the shortest node, and I have 3. I found 3 connections to Z and CC and S, and so I write my memo and override the z equals 6 because if I move to home to C to D to Z, it takes 6. So I override my memo and I found CC. This is a new node, and I write in the memo CC and 10. And next, I move to F, and I found two connections. One connection is CC and C, and I override CC equal 9. And I found CC, but this algorithm checks every node. So if the algorithm won't stop here, I check I and Z. And finally, I found the shortest path and shortest distance and shortest path. This is explain algorithms with diagram. So, any questions so far? I think.
So you determine the priority by the distance instead of the level of nodes, is it?
Yes. Yes. Priority of distance. Yes. So this is I think it's original algorithm. So it considers only distance. Okay, let's move next. So let's implement in JavaScript. So final result looks like this object. Distance is 9 and pass it home and to E to F and CC. And first, I set the variable which holds the tracks of the shortest distance. At the beginning, the distances should look like this. I have B, C, E, and set goes CC. And in the beginning, I set CC to infinity. For instance, at that moment, I already visit B, C, E, D, Z. So at the moment, this object looks like this. I have E3 and G11. And next, I declare the variable which keep track of the passes. Passes is right before each node. So at this moment, passes should look like this. I keep track the one node right before this node, each node. And also, I set the array which keep track which node has already been visited. I make a helper function. This function it takes distances and has been visited array and return the shortest node, which is a node I should move next node. And finally, here's a Dijkstra's algorithm. Dijkstra's algorithm is a little bit long, so I separate the three sections. And then part one is set variables and set the passes initial value. And next, here's the main part. It takes a node and find the connection of each node. And if the distance, find new distance is short, I override memo. If not shortest, I do a debug. And here is a graph structure, which is the same as your hand paper. And this is the helper function, which finds the shortest node I should move next. And here is Dijkstra's algorithm. I start debug. Oh, sorry, I use VS Code and the right side is real code, and the left side is a debug console. And I already set the variables, which is I set as a memo, which is a distance and passes and has been visited. And also which is a node and connection, which is an end. So first, my debug stop here. And now I take a C. It's the first node. And check D, which is next node. And I said I keep the memo, which is D. And next check I move to B. And check the every node B and next G. So G isn't in my memo, so I write G in here. And also G is from B, so I write in the past, which is G. And I write has been visited, CBE, and Z here. And next is now I am F. I check CC and CC. Five. And finally, there are no nodes I didn't visit it. And this while loop ends. Oh, sorry, I missed. Maybe that's. After through the this while loop, I'm going to here, and in this while loop, I set the final result, which is before final result, I set the optimal path, which is from asset and set the node, which is here, home, E, F, CC, and return result. And that's it. Thank you. Bye.